As American warships moved toward the Strait of Hormuz to reopen it for commercial shipping, the operation was no longer just about military control of a narrow waterway. It had become a race against a global oil panic already spreading far beyond the Gulf. Tankers were stacked up at holding points. Shipping companies were delaying departures. Insurance rates were climbing by the hour. Every rumor of another drone strike or another mine contact pushed the pressure higher. Before a single convoy could pass, the U.S. Navy had to do something far more difficult than simply sailing through. It had to build a safe corridor through one of the most dangerous choke points on Earth, while under the constant threat of Iranian missiles, drones, fast boats, and underwater mines. The problem was not only what could be seen on the horizon, it was what could not be seen at all. Iranian naval units had seeded sections of the strait with modern sea mines designed not to float on the surface like the old contact mines of past wars. These were quieter, smarter, and far more difficult to detect. Some rested directly on the seabed. Others were anchored below the surface at carefully chosen depths. From above, there was often nothing to see. No warning buoy, no visible cable, no marker of any kind. But beneath the water, each mine waited for the right set of signatures before detonating. A magnetic sensor could detect the distortion created by the steel hull of a large ship. An acoustic sensor could identify the sound pattern of engines, propeller blades, and cavitation in the water. A pressure sensor could register the change created by thousands of tons of displacement moving overhead. Many of the most advanced mines did not rely on just one trigger. They waited for a combination. That made them harder to fool and far more dangerous to any vessel trying to force a passage at speed, so the fleet did not rush in. As it entered the outer approach to the strait, every ship reduced speed to the minimum needed to maintain steerage. The formation widened. Distances were adjusted carefully. Sonar systems came alive across multiple hulls at once. Detection teams worked in overlapping sectors, each crew scanning a different slice of water ahead, below, and to the flanks. On the combat information screens, the sea no longer looked like open water. It looked like a layered map of uncertainty, filled with contacts that had to be sorted, checked, rechecked, and classified before anyone could move forward. The warships themselves formed more than a transit group. They became a moving shield around the route clearance operation. Cruisers maintained full radar coverage over the airspace. Missile defense crews tracked for ballistic launches and low-flying drone approaches. Electronic warfare teams watched for signal spikes that could suggest remote guidance, drone control links, or targeting radars activating along the coast. Heavy machine guns on open mounts were manned and loaded. Stinger teams took up positions where they could respond quickly to low and slow aerial threats. Marksmen with magnified optics watched small boats and exposed decks through the shimmer of heat rising off the water. Every angle was covered because the danger did not come from one direction. It could come from above, from shore, from the surface, or from the seabed. Ahead of the formation, helicopters launched in staggered cycles and began working the route sector by sector. Some flew low enough for their crews to scan the surface for debris, drifting objects, or signs of disturbed water that might reveal a moored mine line. Others operated mine detection gear, towing specialized sensor packages across the water on long cables. These systems fed a stream of data back to operators who compared shapes, depth returns, and movement patterns against known mine profiles. The work was slow because speed was the enemy. Move too fast, and a mine might never be identified until it exploded. Move too slowly, and the fleet remained exposed longer to every Iranian drone crew, missile battery, and reconnaissance team watching from a distance. Below the surface, unmanned underwater vehicles were deployed in waves. One after another, they slipped into the water and descended toward the seabed, their cameras and sonars scanning the bottom in narrow lanes. Onboard operators stared at live feeds showing sand ripples, rocks, wreck fragments, anchor chains, coral outcrops, and man-made objects that had no business being there. Every suspicious shape had to be studied. A mine could look like a harmless cylinder half buried in sediment. A rock could cast an echo that resembled a casing. A piece of debris could imitate a contact for just long enough to slow the entire operation. The corridor would not be opened by guesswork. It would be opened one verified contact at a time. Inside the operations room, the the picture of the strait changed minute by minute. Red symbols marked confirmed threats. Yellow symbols marked uncertain contacts awaiting review. Green lanes showed sectors already rescanned and temporarily cleared. Officers, sonar specialists, EOD coordinators, and air defense personnel were all looking at the same evolving display. That mattered because mine clearance in a combat zone was never a separate mission. It had to be synchronized with air defense, surface protection, helicopter patterns, underwater drone recovery, and the timing of any eventual convoy movement. If one layer slipped, the entire route could become unusable again in minutes. And while all of this was happening, the pressure from the commercial side kept building. Tankers waited outside the danger zone with cargoes that markets desperately wanted moved. Charterers demanded updates. Port operators further down the chain were already recalculating schedules. Energy traders reacted to every report that hinted the corridor might open or close again. The fleet could not see those screens in financial centers far away, but the effect was present inside the operation all the same. Every hour the strait remained blocked increased the value of every successful mile cleared. The first major cluster of underwater contacts appeared near a narrow section of the approach lane where the seabed changed sharply in depth. The unmanned vehicles found several objects spaced in a pattern that was too regular to be natural. One contact lay deep enough to threaten large tankers. Another appeared partly hidden against a reef shelf. A third was tucked near debris where currents had piled silt over part of the casing. Operators zoomed in. Shapes became clearer. Attachment points, rounded housings, sensor projections, mine-like objects, almost certainly deliberate placements, positioned to force any transit into an even tighter path. The fleet halted its forward movement while the contact group was assessed. Helicopters maintained their patterns overhead. Gunners remained on watch. Air defense crews stayed locked in. No one assumed the mines were the only part of the trap. A clearance effort forced ships to slow down, bunch up, and focus attention downward. That was exactly the kind of moment when an enemy could send drones, launch missiles, or push fast attack craft into the confusion. For the contacts resting in open sand, remotely operated disposal systems were prepared. A mine disposal vehicle was lowered into the water and guided toward the first confirmed device. On the screen, the seabed passed slowly beneath it in gray-green silence. The vehicle approached carefully, held position, and adjusted with fine thruster movements. A charge was placed beside the mine. The operator backed the vehicle away. Everyone in the room watched the same feed. A few seconds later, the detonation sent a muted burst through the water, followed by a heavy plume rising toward the surface. When the sonar team rescanned the position, the contact was gone. That cleared one point. Not the route, not the strait. Just 1 point. The second mine was more difficult. It had settled into broken reef and coral, where the remotely operated vehicle could not safely maneuver close enough for a reliable placement. In that case, the operation shifted to the most dangerous option available: human divers. Below deck, Navy explosive ordnance disposal divers began suiting up. They checked breathing systems, masks, backup tools, cutting devices, communications equipment, lights, and dive computers with the slow precision of men who knew that underwater mistakes did not give second chances. Once fully equipped, they moved into rigid inflatable boats and were carried out from the ship toward the marked position, while the rest of the fleet remained at full defensive readiness. As the divers entered the water, the scene above stayed tense and disciplined. Helicopters continued to sweep ahead. Radars kept turning. Machine gun crews tracked the horizon line and the sky in alternating scans. Ammunition teams moved fresh belts to exposed positions on deck. Small boat watch teams reported every distant wake. Electronic warfare operators monitored for changes in signal activity that might indicate a drone launch or coastal targeting attempt. Nobody relaxed just because the main action had shifted underwater. In many ways, this was the most vulnerable phase of all. The divers descended toward the reef using the coordinates provided by the sonar team. Visibility was poor. Light faded quickly. Their beams cut through suspended particles and reflected off coral, stone, and scattered debris. Then the shape appeared. The mine was lodged deeper than expected, wedged into a narrow gap where coral growth and current-driven sediment had locked it into place. The divers performed a visual assessment, confirmed the likely trigger housing, and reported their findings back through underwater communications. Manual disarming was judged too risky. There was too much uncertainty about the condition of the device and too little room to work safely by hand. So they marked the location and withdrew. Once clear of the area, they surfaced and returned to the inflatable boat. A second remotely operated disposal unit was then sent down with a revised approach path based on the divers' observations. This time the vehicle came in from the side, using the reef contour as partial cover from the current. It edged forward by inches, paused, corrected, and placed the charge precisely where the EOD team wanted it. Again, the vehicle reversed to safety. Again, the feed was displayed to command, sonar, and EOD control at once. And again, when the charge detonated, the underwater blast removed another obstacle from the route. By then, the corridor was beginning to take shape. Not a broad open channel, not a guarantee of safety. Just a narrow, carefully measured path, where the seabed had been scanned, rescanned, and stripped of the most immediate underwater threats. The lane had to be wide enough for controlled transit, but tight enough to remain defensible. Navigation officers defined exact boundaries. Merchant captains would later be required to hold precise headings, maintain fixed spacing, and avoid any deviation outside the cleared strip. One wrong turn could take a ship out of the corridor and back into uncertainty. The final phase was the hardest because it forced the military problem and the commercial problem together. A corridor meant nothing until a tanker actually used it. So while additional rescans continued, the first convoy package was assembled beyond the cleared sector. The lead commercial tanker held position under close instruction. Warships took station around the approach. Helicopters remained airborne. Radar and missile defense crews stayed fully alert. The route existed, but it was fragile. Everyone understood that the first convoy would be the moment any opponent would most likely try to prove the corridor was not truly open. Minutes before movement began, another suspicious underwater return appeared near the edge of the lane. For a moment, the entire schedule threatened to freeze again. Operators checked the shape. Sonar rescanned from a second angle. The contact did not behave like drifting debris. It sat fixed, just outside the intended center line. Another disposal vehicle was launched while the convoy waited under tight control. That delay mattered. Every extra minute increased risk, not only to the fleet but to the credibility of the entire operation. If the first passage failed, even by hesitation, markets would read it as proof that the strait remained effectively closed. The vehicle descended, identified the object, and confirmed it as another mine emplacement. Smaller than the others but still dangerous to a large civilian hull. The charge was placed. The vehicle backed off. The detonation followed. Water rose in a dull vertical column. The sonar picture cleared again. Only then was the convoy ordered forward. The tanker moved first at controlled speed, enormous and slow, staying exactly within the corridor that had cost so much time and effort to create. Warships held their protective arcs around it. Helicopters swept ahead and to the flanks. Gunners watched for drones. Missile teams watched for launches. Operators below deck watched screens full of symbols, ranges, and feeds, knowing that one successful transit would not end the operation but would change its meaning. It would prove that the strait could be used again, even if only under heavy protection. As the ship advanced through the first cleared segment, there was no cheering on the warships. No one treated it like a final victory. There were still more sectors to scan. More mines possibly waiting deeper in the passage. More threats from shore and air. More convoys that would need escort, spacing, timing, and constant overwatch. But the most important shift had already happened. The operation was no longer purely defensive. The fleet was no longer only preventing closure. It was actively reopening movement through the strait. One lane, one contact at a time, one tanker at a time. That was how the safe corridor through Hormuz was built, while oil panic spread across the world beyond it,